Databases are an essential part of modern life. Without them, most computer functions would cease to exist. If you're someone that relies on storing information within a computer, whether as an individual or for your company, then it's important to understand the different types of databases that exist and how you should use them. There are many different types of databases, each with its strengths and weaknesses based on how they are designed. It's especially important for businesses to understand the different types of databases to ensure that they have the most efficient setup. However, some individuals may need to learn this as well. In this video, we'll discuss what databases are, including the most common types of databases that you are likely to come across. Relational databases have been around since the 1970s. The name comes from the way data is stored in multiple related tables. The Relational Database Management System, also known as RDBMS, is the program that allows you to create, update, and administer a relational database. Structured Query Language, also known as SQL, is the most common language for reading, creating, updating, and deleting data. Within the tables, data is stored in columns and rows. The term relational is where a table can be related to one or more tables. This example shows how one row in the customer table is related to many rows in the order table. This is known as a one-to-many relationship. ACID compliance is a must for all RDBMS databases, which means that they must ensure the provision of atomicity, consistency, isolation, and durability. With atomicity, here all changes to data are performed as if they are a single operation. For consistency, data remains in a consistent state from start to finish, reinforcing data integrity. For isolation, the intermediate state of a transaction is not visible to other transactions, and as a result, transactions that run concurrently appear to be serialized. For durability, here, after the successful completion of a transaction, changes to data persist and are not undone, even in the event of a system failure. Some popular relational databases are IBM DB2, Microsoft SQL Server, MySQL, Oracle, PostgreSQL, and SQLite. NoSQL or document databases do not use SQL as its primary data access language. These types of databases are also sometimes referred to as non-relational databases. Unlike relational databases, data in a NoSQL database doesn't have to conform to a predefined schema. So these types of databases are great for organizations seeking to store unstructured or semi-structured data. Sometimes referred to as document-oriented databases or document stores. Document databases are designed to store and manage document-oriented information, also referred to as semi-structured data. Document databases use JSON-like documents to model data. Instead of tables and rows, NoSQL document-based databases use collections and documents. Each document is a single JSON file, which can be a simple or an embedded JSON. Here is an example of an SQL table with columns and rows converted to a JSON document, and an example of an embedded JSON document. NoSQL databases are a great fit for many modern applications, such as mobile, web, and gaming, that require flexible, scalable, high-performance, and highly functional databases to provide great user experiences. Flexibility provides flexible schemas that enable faster and more iterative development. This is ideal for semi-structured and unstructured data. Scalability is designed to scale out by using distributed clusters of hardware instead of scaling up by adding expensive and robust servers. Some cloud providers handle these operations behind the scenes as a fully managed service. High performance is optimized for specific data models and access patterns that enable higher performance rather than trying to accomplish similar functionality with relational databases. Highly functional provides highly functional APIs and data types that are purpose-built for each of their respective data models. Some popular document databases are Amazon Document DB, Apache Cassandra, Couchbase, CouchDB, and MongoDB. Columnar databases are often used in data warehouses because they are great at handling analytical queries. Columnar databases have been around for decades, but offer benefits for modern business applications such as data analytics, business intelligence, and data warehousing. Column-oriented databases store data in columns, where row-oriented databases store data in rows. Instead of keeping a record of every column in a single table in a single row, a column-oriented database will store the data for each column in a single column. Here are some advantages of a columnar database. For multi-purpose, here columnar databases receive a lot of attention with big data applications, including running online analytical processing cubes, storing metadata, and doing real-time analytics. They are efficient for these tasks because they excel at loading new data quickly. For compressible data, data can be highly compressed. This permits columnar operations like min, max, sum, count, and average to be performed fast. Self-indexing uses less disk space than a relational database management system containing the same data. The main benefit of a columnar database is faster performance compared to a row-oriented one. That's because it accesses less memory to output data because a columnar database stores data by columns instead of by rows, so it can store more data in a smaller amount of memory. Initial data retrieval is done on a column-by-column basis. Only the columns that need to be used are retrieved. This makes it possible for a columnar database to scale efficiently and handle large amounts of data. Some popular columnar databases are Apache HBase, Azure SQL Data Warehouse, Apache Cassandra, Google BigQuery, MariaDB, and Snowflake. An object-oriented database is a database management system in which information is represented in the form of objects as used in object-oriented programming, such as C++, C#, and Java. Object databases are different from relational databases, which are table-oriented. Object-oriented databases are often used in applications that require the efficient management of complex data structures and relationships, such as CAD/CAM systems, geographic information systems, and document management systems. Object-oriented database management system, also known as OODBMS, combine database capabilities with object-oriented programming language capabilities. The OODBMS is based on these components. Objects represent real-world entities by combining data with related operations. Classes defines the structure, attributes, data members, and methods. Attributes are data members that hold the state or properties of an object. Methods are functions defined within a class. Polymorphism allows objects of different classes to be treated as objects of a common superclass type and can be used interchangeably. This promotes generic reusable code. Inheritance allows classes to inherit attributes and methods from parent classes. This enables code reuse. Encapsulation binds together data attributes and the methods. Components can be hidden or restricted from direct access. Classes interact with each other through methods without the need to know how particular methods work. Persistence is when the state of an object is saved. With identity, every object is assigned a unique identifier that distinguishes it from other objects. Some popular object-oriented databases are Gemstone, IBM DB2, ObjectDB, Object Store, and Wakanda. A cloud database refers to any database that's designed to run in the cloud. Data is stored and accessed over the internet rather than on a physical on-premises server. Organizations can build databases without the purchase of the physical hardware and infrastructure needed for on-premise databases. Cloud databases are accessed through a web interface or a vendor-provided API. Cloud databases support relational databases, NoSQL databases, cloud data warehouse systems, which includes big data processing, analytics, and vast amount of data, and HTAP, which is hybrid and transactional analytical processing. Some key points of cloud databases are ease of access. Here, users can access cloud databases from virtually anywhere using a vendor's API or web interface. With scalability, cloud databases can expand their storage capacities on runtime to accommodate any changing needs. Organizations only pay for what they use. For disaster recovery, in the event of a natural disaster, equipment failure, or power outage, data is kept secure through backups on remote servers. For data security, here providers use data encryption and access control to protect the data stored in the database. Data encryption ensures that data is protected while it is being transmitted over the internet. Access control ensures that only authorized users can access the data. Optimizing costs can help businesses reduce costs by eliminating the need for expensive hardware and infrastructure. Cloud providers manage the infrastructure and handle the maintenance of the database. Businesses reduce the need for IT staff. Some popular cloud databases are Amazon Web Service, Apache CouchDB, Google Cloud Platform, IBM DB2, Microsoft Azure, MongoDB, MySQL, Oracle, and PostgreSQL. I hope you found types of databases helpful. If you have, click on the like button. And to receive any updates to this channel, click on the subscribe button. Thank you so much for watching.